Okay, sorry for that. With specific matter expertise to uncover actionable insights hidden in an organization's data. So there's a word, there's a phrase there, specific subject matter expertise, meaning all these fields are broad. The field of maths and statistics, the field of programming, the field of advanced analytics, and now the field of AI and machine learning. So when we talk about specific matter expertise, subject matter expertise, it means that there is a subset of each and every discipline that we've talked about there that is going to be central in understanding and working as a data scientist. So to use the graphic, they always say data communicates better than words, or I mean visualizations. So we can use a Venn diagram to actually show the relationship between those fields that we just mentioned. So the red circle is for computer science, the orange
Mm.
one is for maths and statistics, and the gray one is for domain knowledge. So I want you to see how these fields have actually intersected with each other.
Mm.
Computer science, then maths and statistics, they've intersected to form what is called machine learning. And it's actually the subset of computer science that is forming machine learning, and again the subset of maths and statistics that is forming machine learning. We will see what subsets we are talking about here. So this is what we call specific subject matter expertise. Then we have also computer science and domain knowledge. Domain knowledge is understanding the industry in which you are working. For example, if you are working as a front desk receptionist, using word and communication should be your go to skills. So software skills encompass computer science and domain knowledge, in that someone who is working as a front desk receptionist should know Microsoft Office. And that is how domain knowledge and computer science intersect to give us software skills. So this one basically means that domain knowledge is understanding the environment that you are working in. For example, for me, I'm in a technology environment, so I should understand the domain knowledge of where I am working. I should understand the tools that I should be able to use. I should understand the programming languages that I should be able to use, and that's how computer science helps me. Then we have mathematics and statistics and domain knowledge. This is basically traditional research, and you're going to see is something called hypothesis testing. I know you had seen it somewhere though. This
Yes,
traditional,
sir.
yeah, this traditional research is derived from intersection between math and statistics, and also domain knowledge. You're always going to use mathematics and statistics to understand a business problem and investigate what it is. So these three now comes together to form what is called data science, as you can see in the middle there. So we are also going to talk about part of machine learning, part of software skills, and part of traditional research coming together to form what is called machine learning. Well, I don't think if anybody will sit down in a class to teach about domain knowledge. That is basically the environment where you're going to work. But by the end of this course, you will be able to actually know that data scientists can work in any field. For us, as long as there is data, you just get your hands rolling. Now, let's introduce computer science as an element of data science. So, data science borrows heavily from computer science in the following aspects. We'll have programming skills using programming languages such as Python, so R, that is using R, Python, SQL, NoSQL databases such as MongoDB, Cassandra, and big data technologies such as Apache Spark and Apache Hadoop. that is mostly where we are going to borrow from computer science as far as data science is concerned. The knowledge of software development using HTML, CSS, JavaScript, and frameworks such as React, and other programming languages and frameworks such as Java and Spring Boot is highly recommended. And this is beyond this course and will not be covered. We offer a course in software development, so maybe one day if you are interested you can join. Then number 3, you will handle and clean small data sets using spreadsheets. You will clean large data sets using SQL, Python, and R. You will also use big data technology such as Hadoop to gain more insight from data. You will have hands-on experience in using data visualization tools such as Power BI and Tableau to visualize your data by creating reports and dashboards. Then you will build machine learning and deep learning models using modules and libraries such as scikit-learn, TensorFlow, Keras using Python. Then you will get experience in cloud deployment using Amazon Web Service, AWS. That's in a nutshell how computer science is an element of data science. Basically, what we should borrow from computer science to help us work as data scientists.
Okay.
Then in mathematics and statistics, data science borrows heavily from math and statistics in the following aspects. As from mathematics, calculus, you also have principal component analysis. This is basically a combination of both mathematics and statistics, but it's okay. And linear algebra. So then under statistics, you're going to talk about probability, random variables, and probability distribution functions, PDFs. Then we are going to talk about mean, variance, standard deviation, and covariance and correlation. We're going to talk about Bayes theorem, linear regression, ordinary least squares, and Gaussian Markov theorem. Then we're going to talk about parameter properties like bias, consistency, and efficiency, confidence intervals, and hypothesis testing. Then statistical significance, type 1 and type 2 errors, and statistical tests such as the z-test and student's t-test and the f-test. P-value and its limitations, inferential statistics, and central limit theorem, and law of large numbers. That's how mathematics and statistics will help us. Okay, it's very, very common to find these two disciplines used interchangeably. Someone will just refer to them as mathematics, and someone will refer to them as statistics. But at the end of the day, they share. Actually, mathematics borrows heavily from statistics, and so does statistics, which also borrow heavily from mathematics. Personally, Yochita here has a background with statistics. I graduated with statistics and went ahead to pursue a certification in data science once I was done with the statistics course. Exactly what you are doing after pursuing. Yes, exactly what you are doing after pursuing your course. These certificates are very important, very, very much important. Yes. So the earlier you realize it, the better.
Thank you.
Now, business domain, like I told you this one, I don't know how you can be in a class to teach this, but understanding the business domain is essential for data scientists. They work across various industries using data to extract insights for businesses. So this aspect demands soft skills and a thorough comprehension of the industry at hand. For example, if you're working in the healthcare industry, you may analyze patient records to identify trends in diseases or develop predictive models for patient outcomes. And you should be able to develop interpersonal skills, how you're going to work with your colleagues in an hospital setup, like doctors. Most of them, they are the one who are going to consume your data or the results of your data analysis process. Then in finance, the scientists might build algorithms to detect fraudulent transactions or analyze market data to inform investment decisions. Then e-commerce, You could work on recommendation systems to personalize product suggestions for customers or optimize pricing strategies based on consumer behavior. I think the most common one where most of us, so about 70 of us find ourselves in such an industry is the technology. And in the technology industry, you'll find yourselves working to embed AI or machine learning models in a software system. And basically, that's what my day-to-day work encompasses at Tech Savannah.
Okay.
So example roles in the data professional field. So the following are the roles that you might one day find yourself, in addition to your primary role, like the one that you went to school for. You may work as a data analyst, data scientist, data engineer, machine learning engineer, business intelligence analyst. I think you'd seen somewhere I'm a business intelligence developer at Tech Savannah. Then data architect, then statistician, database administrator, data visualization specialist, and quantitative analyst. These roles, they always have a career path that they follow. For example, you can start as an associate data analyst or data analyst intern. In Kenya, we call them data analyst intern. Then you move to data analyst. Then you move to senior data analyst. Then you can now continue with your career progression as you move along the career line. So let's see what each and every role entails and the tools used in each and every role. So roles, job descriptions, and tools in a data professional field. A data analyst, this guy analyzes data to extract insights and inform decision-making process. By the way, when you are a data analyst, then you go ahead and study more on machine learning, then you become a data scientist. What am I trying to say, to insinuate here? I'm just trying to say that data science without machine learning is not data science. It's another field now. So the only thing that makes data science have its fancy name of being a data scientist is when we include machine learning in it. So a role like data analyst do not build models, so this is just a data analyst. And this guy analyzes data to extract insights and inform decision making. Tools mostly used, meaning there are other tools you can find, but these are the most commonly used tools. SQL, I always read as SQL, Excel, Python, using Pandas and NumPy, R, Tableau, Power BI, and Google Analytics for data visualization. Then the data scientist, the man of the room, this guy uses statistical analysis, machine learning, and data visualization to derive insights and build predictive models. So this guy uses Python with his associated libraries such as NumPy, Pandas, Scikit-learn, TensorFlow, and PyTorch. Then R, SQL, Jupyter Notebooks, Tableau, Power BI, Matplotlib libraries, Seaborn, and Plotly. I think you should not worry about all those technical terms because you're going to work with them and you'll actually see you have a hands-on experience with them. So data engineers, this guy mostly design, build, and maintain system for storing and managing data. This guy is like an architect of data using programming languages. So this guy, what he does is actually automation. It's always about automation. In such a role, we really don't have time to be doing things over and over again. So we may need someone whose work is just to come and build us a system that will collect data from the source and store it in a storage system. So this guy is the one that is tasked with that. This guy is actually more of a software engineer than a data scientist. So mostly people who are hired for this role have background in software engineering, but they then decided to change to data science. For example, if you had graduated with software engineering, then you do data science, this role is for you. and they use SQL, Hadoop, Spark, Kafka, Amazon Web Service, Google Cloud Platform, or Microsoft Azure. Then they also use ETL tools. One of them is Airflow. So this guy is more into programming than into data, but he must also know the process of data analysis. When then you have a certain guy here called machine learning engineer. This one mostly anakwanga na 5 to 10 years of experience, 5 to 10 years plus of experience, and he or she develop machine learning models and deploy them into production environments. Then this guy uses Python and his associated libraries like scikit-learn, TensorFlow, PyTorch, Keras. Then Java, Scala, Spark. He also uses things like Docker, Kubernetes, Flask, AWS, GCP, then model deployment platforms. Again, this is also another engineer. So you work as a data engineer during your primary stages of your job. Then as your career progresses, you may find yourself working as a machine learning engineer if you have any machine learning expertise. This guy also more of software engineering during his education background than us who did statistics or mathematics. So mostly for us, we always fall under data scientist who uses statistical analysis, machine learning, and data visualization to derive insights and build predictive models. And also, he can also decide to pursue software development so that he goes ahead and become machine learning engineer.
Okay, got it.
Then we have business intelligence analyst or developer. From the word intelligence, this guy is a CIA of data in a business environment. He should be able to find, to gather and analyze data to provide actionable insights for business decisions and strategies. So he's a DCI or the CIA of data in a business. And he uses
Okay.
Excel, Tableau, Power BI, ClickView, Looker, Google Data Studio, and business intelligence and analytic platforms. Basically, this one is more into, it just focuses on analyzing data to derive insights for business. Then we have the data architect. I think the word is familiar to you.
Yes, very.
But now in this sphere, by the way, he goes, this guy is just another fancy name for data engineer.
Okay.
Except that for him, for data engineer, you can also work as a data analyst or data scientist. But this guy will start to design and create data architectures to ensure data is stored, integrated, and accessed efficiently across an organization. Then, data engineer will come, kazi yake ni kudesign how the new should be. I mean, to design how the data pipeline, we call them pipeline, movement of data from the source all the way up to where it is stored for analysis. This guy is the one who is going to design, then create the architecture. Then the data engineer comes in to implement. So this guy is some senior person in the IT field.
Okay.
And this guy uses SQL, data modeling tools like ERWin or ER Studio, Power Designer, because his work is to design. NoSQL databases like MongoDB, Cassandra, cloud platforms, and data warehouse technologies like Snowflake, Redshift, PostgreSQL, and so on. Then we have a traditional role was called statistician. This one was traditional, by the way, because before the term data scientist came in an organization setup, there was always a statistician. Then they worked in tow with someone like a computer scientist. So nowadays, the terms computer scientist and statistician are fading away, and they're being replaced by a single person called data scientist, who decided, the industry actually sat down and they decided, I think it should be good if this guy who did data science, who did statistics, should learn more about computer science, and this one who did computer science in his college study should learn more about statistics. So the word data science came up, but it's a new concept. I think it gained prominence after 2008 financial crisis, when banks needed someone who could understand both the technology part and the data part to provide to answer business problems. So
Okay, got it.
yeah, so it's basically a new term, data science. But before that, we always had two people in a company, one called statistician and another one computer scientist, and they used to work toe in toe, so hand in hand, and they used to form a formidable team of what we call pair programming. Mwingine hapa, mwingine hapa. So when the industry actually realized that this knowledge can be consolidated into one, and it became a hot cake. So this guy applies statistical techniques to analyze data and interpret results for decision making and problem solving. He uses R, Python, SAS, SPSS, MATLAB, Excel, statistical software such as Stata, Minitab, and Bayesian analysis tools. There is this man who is called now the DCIO of databases. A database is where we store our data in a company, and where we store that data, there must be a security guard for it. This guy is actually tasked with seeing who does what in our database, such that when we lose some of our data, he is held accountable. His name is Database Administrator. He oversees the performance, integrity, and security of databases, ensuring they meet the needs of users and organizations. For you to work as a database administrator, you must start from roles such as data engineer or data analyst. Very, very much recommended. So that because now your role will be more of a supervisor than a doer, if I can use that word.
Okay.
So this guy will actually work more with SQL and the database management system like Oracle, MySQL, Microsoft SQL Server, PostgreSQL, and database management tools like SQL Server Management Studio, PG Admin, monitoring tools, and also even non-relational like NoSQL databases. Then there is this guy who is data visualization specialist. This one loves graphics, but for him, he felt like those graphics should only be done on data. So he decided to specialize on visualization. So what he does, he creates visuals, then a data scientist comes and gets insights from the visuals. But this guy, I must tell you, is a specialist. When you call him a specialist, he is a specialist. And is the one that is mostly they do have some background in software engineering, and therefore they are used to develop data visualization tools like Power BI was developed with the help or with the input of data visualization specialists. Then there is this guy who is called quantitative analyst. More the same as statistician, except that this one has a background in mathematics. You see, talk about mathematics. The guys who went to college to do a Bachelor of Science in Maths, then he felt like that was not enough. He went to university, then a master's in something. They always given some fancy name, I don't know, computational mathematics. Yeah, I think you've come across such like guys. But
Yes, I've come across such a.
Yeah, they're one of genius though. So then he felt like this is not for me. Then he went ahead and something like PhD, Doctor of Philosophy in Mathematics or something. So this guy will work as a quantitative analyst. He applies mathematical and statistical techniques sorry, to financial and risk-related data to inform investment and trading decisions. This guy works mostly in industries such as online e-coins, such as bitcoins, Ethereum. He also can be found in big banks who have decided to use mathematical and numerical analysis to derive it. Sorry, got some cold.
Sorry.
Thank you. So he uses Python, R, MATLAB, Excel, statistical modeling software, financial modeling software, Bloomberg Terminal, quantitative trading platforms. He is also employed. They are also the people behind stock exchanges, the Nairobi Stock Exchange, the New York Stock Exchange, and all those fancy charts. Quantitative analyst. I'm sorry, please spare me of this. I cannot be a quantitative analyst.
Okay.
So there are some of the roles that you can be called when you work with data, but also depending on the industry you're going to work for, they can have other name. Like you see Texas, they call me the business intelligence developer. And some of these roles, for you to reach to be a data scientist, to have the name, the tag data scientist below your name, the title.
Yes.
I have to prepare you before that. You have to start from somewhere like being a data analyst, data engineer, the statistician, database administrator, and there is a career path, by the way.
Okay.
So, for example, so there's a career path we always follow. So here we'll find someone called machine learning engineer, or even senior data scientist. Senior data scientist. So as we begin, we always start our roles as intern, or in the US they are called associate. So you can start as associate data analyst. That's wrong. Okay, associate data analyst, data engineer, or a company can decide to just call you directly data scientist, which is very, very uncommon. Then as you progress, you drop the term associate just before your name, then you're called data analyst, data engineer, and so here you start specializing, DB admin. Then as you progress, you become senior data analyst, or you also get something to do with data architect. Then as you progress, you now get into data science now. This guy progress basically means, by the way, for you to have this career path, you have to exhibit what is called continuous learning and professional experience. So huyu tutamwelewa 0 to 1 years of experience. In Kenya they always ask for 5 years of experience. I mean, mshanga tu Kenya. Then 1 to 2, 1 to 3, then 3 to 5, then 5 to 10, then 10 plus. So it's basically plus. This one data scientist. Then is when we now move to machine learning engineer. So based on how you play your cards, things can work out for you. For example, for me, I began as a business intelligence developer at Tech Savannah. Then I played my cards right by pursuing a certificate in data science.
Okay.
Certificate in data science. Then I now became a data science tutor, but just still maintaining my name of BI developer, something BI or business analyst. So use it also ukiona after we are done with the course BI, business analyst, DA, DE, DS, apply.
Oh, okay.
Yeah, so as you progress, your interest, you should now be like, I think, for example, personally, my interest is to be machine learning engineer. So I realized that for me to achieve that, I have to work more on my machine learning skills and expertise. So
Okay.
certifications online, physical certifications, and so on and so forth, very, very much important.
Okay.
Okay, up to that point, is there any question you may need to ask?
Regarding the careers, so I kind of have the sense that some careers are quite related and not really in terms of progression. So, for instance, like if you're sitting as an analyst, the progression to data science, then okay. So you get to data science, and the trajectory towards, say, an data architect or an ML engineer. Is an ML engineer, being built upon, or being either a data analyst or scientist, all the way to engineering.
That's very correct. You understood this. That is
Okay.
very, very much correct. And for you to work as an ML engineer, they require you to have worked as a data analyst or senior data scientist or somewhere. But
Okay.
some of us, for example, someone can be a senior data analyst. This one basically means that he's more into analyzing data with just a few skills on machine learning. But this guy just decides from nowhere that, you know what, let me take a course like Amazon machine learning course, machine learning practitioner course. I think this certificate is always a hot cake in the market.
Okay.
Then once he undertakes this course, Amazon machine learning, he was a senior data analyst. Then all of a sudden he becomes an ML engineer or some senior data scientist, or even a team lead. You can even be, I think the last one is when you're now a management team lead, is something sort of.
Okay.
Yeah. So yes, you understood this. This is very much correct. And it's just like I said before, it basically depends on how you are going to play your cards. It's always about how you play your cards. If you play your
Okay.
cards wrong, you will get it wrong. If you play it right, you'll get it right. Because I know someone who has worked for 10 years plus in this industry, but do not know anything to do with machine learning. So this guy basically was not interested in learning machine learning. So career progression yake ni vitu kama data analyst, senior data analyst, associate data analyst, senior data analyst, then team lead for data analyst. You see?
Okay.
Yeah, so it's always about how you do your things. And that's why sometimes also certificate in software engineering is also good if you have, because they help a lot.
Okay.
Any other question? That was a good question, and a good observation, by the way.
Okay, thanks. So, so the likely entry points to after taking the certificate will be the BI and or BA, the analyst roles. Are there any others?
BI, BA, DA, DE, DS, but the term should be associate, or in Kenya we call them intern, data engineering intern, data science intern, data analyst intern. But in the US and the West, they call them associate someone, associate BI developer, associate BI analyst, associate business analyst, associate data engineer, associate data analyst. This one basically means these guys, they are just getting started on their fields. And
Okay.
as you move along, how you play your cards. So you see this guy akiwa hapa akasomea certificate in data science, akakuwa
Yes.
data engineer or data scientist somewhere.
Engineer.
Then kufika somewhere akaamua kwenda kusoma certificate in machine learning practitioner from AWS, akakuwa machine learning
Yes.
engineer.
Okay.
So by the way, in any tech field, the two are always very important: continuous learning and professional experience.
Yeah.
Like personally, I learn a lot because I know what the demand my profession has.
Okay.
Yes.
I think I'm comfortable now.
All right. So as we progress, you should try and find your niche and actually try understand where you may want to work one day after you're done with the data science course.
Okay, thank you.
Yes. So let's introduce this. We shall begin practically tomorrow. Computer science for data science. Now, this is the study of computation, information, and automation. So data engineer ako hapa sana. This guy does a lot of, but I do a lot of automation. Like, and sometimes simu inakuwa mshadi usiku. That's how funny it is when you build a data pipeline to collect data from a source to a destination. Then midway it breaks. Your team lead will just call you, even if I've received calls most of the time. Ebu angalia hiyo kitu yako ni kama imebreak. Hiyo pipeline, they use the term hiyo kitu yako ama hiyo pipeline yako ina leak to mean there is something somewhere that's wrong. So automation basically is basically a way to program something so that it happens without without someone's input. Now wewe sasa kazi yako ni supervisor tu. Then it combines theoretical and applied disciplines such as algorithms, theory of computation, and theory of information. Those are theoretical disciplines. And design and implementation of hardware and software, applied disciplines. So during designing and implementation of software, computer professionals always give instructions to computer applications in a process called programming.
Okay.
Yes, sasa inaanza kuwa interesting. So what's computer programming? This is a systematic process of creating sets of instructions, including predefined words, symbols, logical structures, and algorithms to enable a computer to execute specific tasks accurately and efficiently. In our role, because now you are becoming data scientist, everything is always about systematic process. You saw that data science was a systematic process. Now this one is also a systematic process.
Okay,
now,
got it.
In this systematic process, it basically means that one item that you are doing depends on the previous one, and actually the previous one is used to build the next piece of action that you want to undertake. So you use predefined words. Predefined words are basically, we call them syntax, and they correspond to each and every programming language. Each and every programming language has its own syntax. Symbols, logical structures, that is basically reasoning, and algorithms to enable a computer to execute specific tasks accurately and efficiently. So these sets of instructions, including predefined words, symbols, logical structures, and algorithms, are called codes. And the process of writing these codes is called coding. So the codes are written in and implemented by a prior developed computer applications called programming languages. And now, a programming language is a formal set of rules and syntax used to create instructions within a computer application, enabling developers to communicate with computers and create software solutions. Now, a programming language is like a constitution of a country. It is the one that directs you on how to do something, what to do, how to do it, and why it should be that way. Formal set of rules and syntax. So these computer applications are either text editors. We say that, remember we said, is a set of rules that we use to create instructions within a computer application. So these computer applications that we are talking about are either text editors or integrated development environments, IDEs, where we write our codes.
Okay.
So text editors versus IDEs. Text editors are simpler tools primarily focused on text editing, while IDEs are comprehensive software environments, software development environments. Environments tailored for software development, offering a wide range of features and tools to streamline the development process. So basically, if I can talk about, yes, basically we have a text editor. We can do a simple tool. Then we have an IDE. So in short, someone can start developing a text editor, then decide to change it into an IDE. So he adds some functionalities like a very nice user interface or user experience, a very nice one. So when he does this, it becomes an IDE, integrated development environment. In this reading, we are going to use one called PyCharm. We will also use Jupyter Notebook IDE. Jupyter Notebook. And we'll also use Visual Studio Code. So others you may find being used in any setup that you may join include Vim and it's associated on Vim Plus. Some experienced developers like solutions data architect, these guys use PowerShell or command prompt to write codes. Mimi hata nakushanganga unapata mtu anaandika. By the way, it's very difficult to write codes in this thing, but some of them these guys are seniors and they know how to do these things, man. And
Okay.
command prompt or even this one for macOS, it's called terminal.
What? Okay.
So these are where some of the places we write our codes. If you are a Java developer, you will find yourself writing it in what is called Eclipse. If you are a C++ user, these are basically programming languages, you will write in what is called NetBeans. This one was my first language to learn programming.
Okay, nice.
So text editors are basically simpler one, and we are going to use them also. Know that
Okay.
we're going to assume them. So there are simpler ones than their work is mainly used to edit codes, not to write codes. To edit codes, and they include things like unaiko hapa ndio hii the name is here. I just used it yesterday. I don't use often, and that's why it's very need to forget about it.
Okay.
Okay, nikikumbuka nitaonyesha. Iko hapa ndani. Ama nitafute kwa program.
Okay.
So basically, those are the tools that you are going to use mostly to ensure the Sublime Text. This one here.
Okay.
So a good example is the Sublime Text. Now, based on this diagram, you can notice something, by the way.
Yeah.
Where is it? No, here. Based on this diagram, all IDs are text editors, but not all text editors are IDs. Ndio?
Yeah, it's true. It's true. Yeah.
Yeah. So, in short, if you want to edit your code, you can use an ID to edit it. So, when you talk about examples of text editors, all other IDs that we talked about plus Sublime Text, which is basically you develop to be a text editor, not an IDE. But some people, senior developers, as a matter of fact, use it to to write their codes. Then what about frameworks and libraries actually? On top of a programming language, or on top of programming languages are frameworks. These are basically pre-built collection of codes, tools, and conventions designed to provide a structured approach for developing software applications. They aim to simplify and expedite or speed up the development process by offering a foundation of reusable components and predefined structures. What these ones are, they are basically someone somewhere just thought like, I think writing codes from scratch may be difficult, so let me relieve the other developers of some work. So for him, as a senior developer, then he gives you a predefined codes for you to use.
Okay.
Very many people do not love frameworks because they feel like frameworks make you lazy. Most of the things have been done. So the same to libraries, we are going to use them, and therefore leading us to programming languages with their frameworks, uses, text editors, and IDEs that you're going to use. The first one in the list will always be Python. Frameworks like include Django and Flask, and it is used for web development, data analysis, scripting, and machine learning. And this is the one we are going to use primarily for this course. And we are going to write in text editors. We are going to use Sublime Text, Atom, VS Code. Then the idea we are going to use include PyCharm, Spider, PyDev, Jupyter Notebook. This reading we are just going to use two, PyCharm and Jupyter Notebook. R is used for, it doesn't have a framework, neither does it have a text editor, but it is for data visualization and analysis, machine learning, statistical programming. The IDE used in this case is what we call RStudio. Java framework is Spring, Hibernate, or Struts. It's used for enterprise applications, web development, and Android app development. Text editors used in this case are Sublime Text, Atom, VS Code, Visual Studio Code, Eclipse, IntelliJ, IDEA, and NetBeans are some of the IDEs that are used. JavaScript frameworks include React.js, AngularJS, and Vue.js, used for web development, mobile app development, and server scripting. Text editors include Sublime Text, Atom, and VS Code. And IDEs include Visual Studio Code, WebStorm, and Atom. C and C++. C was the first language, then C++ was its variation. Frameworks include Qt and Boost, used for system programming, game development, and embedded systems. Programming language text editors include Sublime Text, Atom, VS Code. IDEs include VS Code, CLion, Code Blocks. C# by Microsoft. Frameworks include .NET Framework, ASP.NET Core, used for Windows applications, game development, and enterprise software. We use editors such as Sublime Text and Atom, VS Code, then Visual Studio Code, and MonoDevelop, Rider, and Rider as IDEs. HTML, CSS, these are not programming languages but are tools for web development and front-end design. Frameworks include Bootstrap and Foundation. Then, as you can see, editors include Sublime Text, Atom, VS Code. Here, Sublime Text is everywhere. Visual Studio Code. In high school, we used to say, ni kama msichana sura mbaya, anakuanga kila mahali. Then, PHP, also another programming language. You will be careful right scrolling this, keeps on disappearing.
Okay.
Framework is Laravel, Symfony, or CodeLighter. It's used for server-side web development and dynamic websites. And its framework includes its editors, Sublime Text, Atom, VS Code, while IDEs include PHP Storm, Visual Studio Code, and Sublime Text. Ruby, another programming language, is actually used for its framework is Ruby on Rails, used for web development or P, and those are its editors, and its IDEs include RubyMine, Atom, Visual Studio Code.
Got it. A quick one. So, is there any superior IDE to the other, or how does the hierarchy go?
Nice question. That's a very good one. ID depends on what you want to do. For example, Visual Studio Code can help you. Is a commonly used IDE in any organization. We use it most often, but when it comes to data science, it cannot give you a powerful visualization that you may need as a data scientist. So we always go for Jupyter Notebook, which was specifically built for that purpose, data analysis. So to answer your question, IDE always depend on what you are doing and the programming language you are using. So if I'm using Python, the best IDE is always PyCharm, because it was specifically built for Python. If I am using if I am using something like C++, the best IDE is always CodeBlocks or NetBeans, specifically built for C++. So to answer your question, there is no better IDE, but IDEs always goes hand in hand with a programming language and what you are doing, so that you don't have this issue of configurations. You just use the IDE that has already been configured for you.
Okay.
Yeah. Last slide for this. So the Data programming language, as discussed earlier, data science has its core programming languages, Python and R. However, since a data scientist, I want you to get this phrase, this sentence, very important. Since a data scientist is a software engineer who excels in statistics more than any statistician does, and a statistician who excels in software engineering more than any software engineering does, it is beneficial to add as many programming languages and skill set to your repertoire as possible.
Okay.
So we are always required to know software development and at the same time know statistics and mathematics. I think I explained that with being a statistician and computer scientist.
Yes.
So this reading will cover Python, R, SQL, NoSQL, big data and cloud computing. So now that you've gained insight into what computer science and data science entails, we shall begin tomorrow with Python programming.